Hello, third graders. It is time for another math lesson, and today we are going to work on lesson 310, and we're going to work on the commutative property of multiplication. That's a big word, but we're going to talk about it later, and it will make a lot more sense than it does right at this moment. But first, a number talk. I have the number 86. I want you to get out your whiteboard and your marker and eraser, and I want you to write down all the ways that you can make the number 86. Pause the video, write them down, and then I'll come back and share some of my ideas. All right, now that you're back, here are some ways that I came up with that we can make 86. I can simply add 80 plus 6. That's 86. I could have 85 plus 1. That makes 86. I'm thinking that I could have 40 plus 40 plus 6. That makes 86. What about 50 plus 30 plus 3 plus 3? That makes 36. Now I don't have to always just do addition. What about 90 minus 4? That's 86. 87 minus 1 is 86. 100 minus 14 is 86. And maybe I could think of some multiplication. Now, why wonder if I think of 86 and I think, well, 43, well, wait, 43 plus 43 equals 86. So that means 43, not divided by Mrs. Flurry, but 43 times 2, that's 86. Because if 43 plus 43 is 86, then 43 times 2 is 86. And hey, I can remember about fact families, right? So if I know if 43 times 2 is 86, then 2 times 43 is 86. And then I know that with a multiplication or a fact family, it's usually 2 multiplication and 2 division. So I could say 86 divided by 2. Oh, here's what I was just thinking. But when I write it down, I know, well, that's not right. And here's why. I was thinking fact families and making 86. And I know when I do a fact family, I have to have the same 3 digits. But when I make this be a division problem, am I going to get 86? I'm not. But you know what? It's okay to write an idea down, figure it out, and decide, oh, that doesn't work, because I am self-checking. I am self-correcting to see if the problem that I came up with works. Sometimes they work, sometimes they don't. So I'm just going to go ahead and cross that off. I'm going to do one more multiplication problem, though. I know about the rule of 1. 86 times 1 is 86, because I know that any number multiplied by 1 is going to be that number. We are going to work on some mental math and fluency. You're going to need your whiteboard, so make sure it's handy. You divide 25 rulers equally among 5 groups. How many rulers does each group get? Let's read that problem until we understand what we need. You divide 25 rulers, so that's what I have. I have 25 rulers, and I need to divide them equally among 5 groups. So that means each group has to have the exact same amount to be equal. So when in doubt, draw it out. Group 1, Group 2, group 3, group 4, group 5. I'm going to give each group one ruler until I get to 25. Nice and neat and tidy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I have equally divided those rulers. So how many rulers does each group get? Each group gets 5 rulers. And a number model that would go with this problem, and I have to start with the numbers that are in the problem. So it's going to be 25 and 5. I had 25 rulers. I separated or divided them into 5 equal groups. So 25 divided by 5 is 5. Let's try it again. Erase those boards. You use 100 paper clips to make chains with 10 paper clips each. How many chains do you have? Well, let's read that problem again. I have a total of 100 paper clips. I'm going to make chains that have 10 paper clips each. How many chains do you have? Excuse me. Well, when in doubt, draw it out. And, you know I could do tally marks, but I'm thinking that could be a lot of tally marks. But there's something else I could do. I could just do groups of 10 because I know there has to be 10 paper clips. So there's a chain that's got 10. This has 10. This one has 10 and 10. And I'm going to just count as I go. That's 10, 20, 30, 40. That's going to be 50, 60, 70, 80, 90, 100. So each chain or box has 10 paper clips. So how many chains do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can make 10 chains. All right. Erase it. Here's one more. You have 50 marbles and put 5 in each bag. How many bags do you need? Well, let's take a look at what we know. We know we have 50 marbles, and I'm putting 5 in a bag. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to count so far. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. How many bags do I need? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be 10 bags. There we go. If I can move that, 10 bags. So we're going to talk about the turnaround rule for multiplication. And if we would go back to that very first page, it said the commutative property of multiplication. The commutative property for multiplication is the turnaround rule. And we've kind of talked about that once before this year. So we are going to hopefully get through these next pages pretty quickly. So let's say you have 8 apples for sale and you want to display them in an array. How many different arrays can you make? Well, I know that I could have 4 groups of 2, and my multiplication problem would be 4 times 2. But I could do 2 rows of 4, and then my number model would be 2, oops, come on, 2 times 4. This is an example of a turnaround fact, because 4 times 2, if I turn my array around, I could have 2 times 4. Okay, let's try that again on Math Journal page 88. So you can get that out, pause the video, get it out, and then come back. And you have a dice in your toolkit. So you want to get that dice out too. And here's what you do. It's pretty simple. It's kind of fun. You're going to sketch an array using 2 factors and record a number sentence to match. So you've got your 2 dice, or 1 dice, roll it once, maybe you get the 3. Roll it the second time, maybe you get the 4. Okay, so you're going to make an array. You're going to make an array for 3 going down, 4 going across, because the 3 and the 4, 3 times 4, that's going to equal 12. Now you're going to use those same numbers, but you're going to make a different array. So this time I'm going to have 4 in a row, 4 rows, and 3 in each row. So it's going to be 4 times 3. These are called turnaround facts. It's the same factors, but I'm turning them around, putting one first and then the other one first, and I'm still going to get the same answer. So for example, if I rolled 2 times 3, all right, there's one array, there's another array. They match because I'm using the same factors. I'm using 2 and 3. This one's going the long way, this one's going up and down. They're called turnaround facts because I'm using the same digits. So that's what you're going to do for numbers 1 and 2. Roll your dice. What did you get? Write them down. Make an array. Write the number sentence. Make an array. Write the number sentence. They should be turnaround. This is an array for 3 times 5, which is 15. And I can do the turnaround by making it be 5 going down and 3 in each row. And then my turnaround fact is going to be 5 times 3 equals 15. Let's try it again. Here I have 4 going down, and there's 2 in each row, so it's 8. I'm going to rearrange that array and have 2 rows. Oh, Mrs. Fleur, you don't know how to count very well, do you? That wasn't a... That's going to be 5. Teachers make mistakes too, just to show we're all human. So the turnaround, I've got 2 going down and there's 5 in each row. So it's 2 times 5 equals 10. All right, moving along, I want to show you a tool that is going to be in your folder. This is called a multiplication and division facts table. I can use this to help me solve my basic multiplication facts. Here's how you do it. It's pretty nice and pretty handy. So let's say I had 3 times 6 and I couldn't figure that out. I could make an array, but I have a different tool that I can use. So I go to 3 and I go to 6 and I just slide my fingers over to where they match up, and the answer is 18. Well, let me do my turnaround. 6 times 3, go to 6, go to 3, slide it over, slide it down until it matches, and my answer is still 18. So this is a great tool to use to help you solve multiplication facts. And a game for you to play, you have in your folder this sheet of cards that you can cut out. Here are the directions. You can play Array Bingo. You're going to follow the directions, have a partner or family member play with you, and you're going to work on playing Array Bingo. Maybe there'll be prizes.